All right, hey guys. So for this video, it's just gonna be a little quick video going over what you need to know for exam 3. But before we do that, there is important information about the final exam that I've just been made aware of regarding material. So this is a email from my boss, from the head of the department. And so here's just to clarify on how the exam or the material on the exam in terms of things we talked about last class or yesterday based on how it's going to be run, like the logistics of it. We're still figuring that out with the lockdown browser. I'll post a link for the lockdown browser soon. But basically, so the exam will be 60 questions worth 5 points each, all multiple choice. So that's going to be a total of 300 points. And it'll be cumulative. It will cover all the chapters in 125 that in the class, which that really includes chapters 1 through 12 and a little bit of 13 now. So I thought it was just going to be 1 through 11, but apparently it's up to her. So she's made it differently, but you'll be prepared regardless. So and also roughly 2/3 of the exam will cover the latter part of the course. And obviously the beginning part of the course will be included as well. You still need to understand solutions, thermochemistry, stoichiometry, on all the basics we've learned in the first couple chapters. But the later stuff is going to be stressed, which you have light, magnetism, electromagnetism, you have energy of photons, all those different physics equations we talked about, bonding theories, dipole moments, electronegativity, bond angles and shapes, Lewis structures, the VSEPR shapes, and valence bond theory. That's what VBT stands for. We didn't cover that yet. That's the later half of chapter 11, but we're going to cover that in the last class we have. So the last class is going to be pretty stocked full of stuff you need to know for the final. And also I'll post a final review after that. Or I think I already posted videos on final review, but I'll talk about that more on Monday. Also hybridization. So hybridization we basically covered, basically determining if I give you a structure, what's the hybridization of one of the atoms? And if there's 2 bonds in it, if there's 2 bonds, it's an SP, it's an SP. So things like that. So, or SP2, stuff like that. Or depending on what the bonds are. But we talked about that a little bit in the lecture. But we will cover it more in depth in the last class. And also some solids and gases and intermolecular forces. So intermolecular forces is more of chapter 12, 13, and 14. And we didn't really cover that yet, but the plan still stands for the last class, meaning next Wednesday. We're going to go through a little medley, kind of going through the key concepts involved in solids, liquids, gases, and intermolecular forces. It's actually pretty interesting. So stay tuned for that. So yeah, that's basically it for the final exam. We will be using the lockdown browsers, but I have the link for that, like we saw if you joined us for the lecture on Wednesday. But in terms of the logistics, and the exam's going to be on Moodle, so you need to log into Moodle using the lockdown browser, and then just access the exam. And the exam's going to pop up and probably say you need to be using a lockdown browser to access the exam. So my boss is adding the lockdown exam to my Moodle, into the course Moodle soon. She'll be doing it soon. So stay tuned for that. Okay, so now going over things that you need to know for the exam. There it is. So study guide, right. So chapter 7, the only thing for chapter 7 is going to be Hess's law. So there are some examples of Hess's law in the practice exams, which are on Moodle. In the unit, I think there's practice exams from fall of 2017 and 2018. So those are there for you to study from. And just basically, if you go through the slides, you can figure it out as well. But we went over that. You gotta add, subtract, multiply, divide the equations to figure out the main equation and its heat of reaction, enthalpy of reaction. For chapter 8, there's gonna be a lot of formulas that will be given, such as energy of a photon. So it would be E equals NHF, and H is your Planck's constant. And yeah, so like equations like this will be given. So N is representing the number of photons. So wavelength of a photon and frequency of a photon. So you remember C equals lambda nu. So that means your frequency and your wavelength multiplied together equals your speed of light of 3.0 times 10 to the 8th meters per second. Things like that, fair game, and they will be given to you. The photoelectric effect. So remember we talked about how that whole thing works, where a beam of light comes through and it excites electrons off of a metal surface and gives them a certain kinetic energy. Your job is going to be in a multiple choice question or an open-ended question is to go through that entire process using the energy of the incident photon or photons. And well, it's really one photon to one electron, but using the energy of the incident photon, what is the energy, and using the minimum binding energy, meaning the energy required for the electron to be kicked off of the metal, subtracting that from the total energy of the incident light, and then the remainder will be converted into the kinetic energy of that excited emitted electron. So your job is to be doing problems with that and figuring out one of those things. Binding energy, yeah, we talked about that already. So the Rydberg's equation. So we didn't talk about that we didn't call it that, but basically it is this equation. So the energy of an atom, or energy of electrons of a hydrogen atom, when they go from one energy level to another. So you remember we talked about spontaneous electron emission, that's what it's called when there's light and the incident light goes and excites a photon, or sorry, excites an electron. The electron gets excited to a higher energy level. Then the electron will spontaneously come back down to its ground state. The energy released in that process can be determined from this equation using NF2 or NF squared. NF is going to be your final energy level, and initial is going to be your initial energy level. So if it goes from 3 to 1, your final energy level is going to be 1, and then it's going to be minus 1 over 3 squared. And then your RH is your Rydberg constant, which is going to be here. So that's basically the energy of a photon. So yeah, so you'll be using that equation. Okay, what else? So don't worry about the difference between absorption and emission. I mean, you kind of already know that, but there's not really going to be any conceptual questions on that. Calculate the wavelength of photon absorbed or emitted during electronic transmit. I mean, we kind of did, that's using the equations. You can kind of disregard 9. List atomic orbitals and atoms and quantum numbers. Quantum numbers is important. So understand the meaning of the 4 quantum numbers. You have N, you have N, you have L, you have ML, and you have MS. So know the differences and then know the, you don't have to know in depth of what they each mean. Like molecular, well, spin, one electron has to spin in one direction, one has to spin in the other, but don't go crazy with knowing the definitions of each. Just know the rules of each. So you know that N is the principal energy or principal quantum number that can be 1 to infinity. And then L has its limitations. It can be from 0 to n-1. ML could be from negative L to L. And then MS can only be 1/2 or -1/2. Things like that. And you also need to be required to know if a set of quantum numbers is allowed or not allowed. And if you can also determine the number of electrons that can have a given set of quantum numbers. So let's say how many electrons can be described by n equals 2, L equals 1. And the answer is going to be, if L equals 1, ML could either be -1, 0, or +1. And then you'll have 2 MS's for each one of those, and the answer is 6. Or a little trick, if you know what we talked about, how the L directly corresponds to the letter orbital, meaning L equals 2 L equals 1 corresponds to the p orbital. And you should know, every p orbital has a maximum of 6 electrons. So that L equals 1 can represent a maximum of 6 electrons based on its equality to being a p orbital. So things like that. All right, chapter 9. So write down all configurations of atoms or ions. That should be a given. We covered that a lot. And that includes the exceptions. So, when you have a D9, such as copper, or not copper, copper. If you have a D9, such as copper, you know that it takes 1 electron from the previous s orbital, and then it fills the d orbital, makes it D10. Even though it's in the 9th position, it makes it D10. So things like that. And that same thing is for chromium. All right, so calculate the number of shielding electrons and effective nuclear charge. So I spent a whole time talking on effective nuclear charge and the meaning of it. So that's important for understanding atomic radius, electron affinity, and ionization energy. So those are the big three trends that we talked about. So those are important. Also diamagnetic and paramagnetic. Diamagnetic is when there are when there's wait, hold on a minute. Paramagnetic, let me just see. So paramagnetic, when you have a free electron. Let me just double check. I'm tired. Here we go. Yeah, so net unpaired electron. So paramagnetism is when you have an unpaired electron, and then diamagnetism is when you have all your paired electrons. So the way to figure that out is to do your orbital diagram. So if we bring that tab back up, you see how the orbital diagrams are completed for here. So if you're unsure, write in your individual orbitals and the subshells. So I don't know why there's 5 boxes for 2p here. There should be 3, but yeah. So either case, you're gonna fill them up. So so yeah. Next, chapter 9. Yeah, so understand atomic radius. It goes increases going down, decreases going to the right. Electron affinity, it increases going to the top right. Ionization energy, not only know to arrange atoms in increasing or decreasing ionization, but understand what we talked about, how the first ionization energy is always the easiest. The second one increases, and it increases for every atom, the more electrons you remove from it. But it increases a drastic amount when you go from a noble gas configuration to taking an electron away from a noble gas configuration. And that hugely increases the ionization energy. So you may need to compare different, let's say, like we did in class, like magnesium and potassium, right? So potassium is very easy to remove 1 electron. So the first ionization energy is very small. Then to remove the second one, it will then have a noble gas configuration. That will be extremely difficult. So the ionization energy for the second ionization from potassium would be maybe 10 times or even 20 times the first one. Whereas for magnesium, the first ionization is easy. The second one is also pretty easy. It increases, but it's still pretty easy. The third one is going to be the most difficult. So knowing those differences is important. Then right and balance, don't worry about that. Don't worry about 18 and 19 here. For chapter 10, know your different bonding: polar covalent, pure covalent, ionic. Melting point based on its size and bond length, bond strength, all those things that we talked about. Based on, let's say, an ionic bond, what's stronger, a +1+1 or a +2+2? And the answer is a +1 -1 or a +2 -2. And the answer is 2 and 2. And there is equations that show you that. So the equation you have, remember, it's Q1 times Q2 over R, right? So it's dependent on the radius and the charges of the ions to determine the energy that is that needs to be put in order for them to release, in order for them to break apart, or the energy required for them to form. So that's also fair game. Energy of atoms according to arrange atoms in terms of electronegativity. So you know, electronegativity is a very similar trend to electron affinity, where it increases going to the top right. Lewis structures, very important. So sometimes you need to do normal Lewis structures that in every atom obeys its set of rules, and the octet rule. But I say its set of rules because like things like boron, beryllium, and hydrogen don't follow the octet rule, whereas things like sulfur and phosphorus could actually exceed it. And also draw Lewis structures in terms of minimizing the formal charges, like we talked about. So formal charge is a key concept as well. Resonance structures, just know you can move the bonds around. That's basically it. As long as it's the same structure, same connectivity, and the same amount of bonds. So if you have NO3, for example, the only way to write NO3, or the most stable way, is if you have one of the oxygens double bonded to the nitrogen, and then 2 of them single bonded. That minimizes the formal charges for the most electronegative atoms. That's a key concept that they don't really talk about. Well, I think one slide said it. you want to minimize formal charges for the most reactive elements, meaning the most electronegative. So fluorine, you do not want fluorines with formal charges. That means the structure would be very unstable. So yeah, it's like trying to calm down the belligerent guy at the bar. You want to, you don't want him to get in a fight. So here's another beer on me, kind of thing. So you make them happy. That's what you need to do with these structures. So chapter 10, identify equivalent, non-equivalent resonance structures. Yeah, basically what I just said. Count number of equivalent resonance structures. So let's say if you have NO3, there's 3 resonance structures for NO3 because you can put the double bond on oxygen 1, oxygen 2, or oxygen 3. So just know that. Just know that that's a thing. I kind of explained that. I mean, I know they put a big emphasis on resonance structures because in organic chemistry, you cover it a little bit more in detail, but it's really, you're just rotating the structure and you know the bond can move. That's basically it. Nothing crazy. Okay, and then for chapter 11, there actually isn't much on chapter 11 on third exam, which is why we didn't go over it in much detail, and we only went over half of it last class. So the only thing you'd have to know is your molecular and electron geometries, know the differences between them, and meaning like why use one versus the other, where your molecular geometry tells you the shape of the actual molecule. The electron geometry tells you the shape of the electron clouds around the molecule based on the free electrons. But the molecular geometry takes into the account the effect of those free electrons on bonded electrons and actually pushing the bonds and changing the angles of bonding for covalence only. So also determine polarity of a molecule based on knowing the shape. So kind of everything we talked about last class. Hybridization will not be on the third exam, but it will be on the final. And also the valence electron theory will also be on the final, but we will talk about that stuff on next Wednesday. So I'm going to have a whole thing ready. And also on Moodle, I'm going to go on Moodle real quick and show you. I'm going to go on Moodle and show you. So here's what I just posted in the final exam section. I posted this is from another professor. It says final exam review video course overview. I'm not sure how long it is, but Professor Charoff is pretty good. I think I pronounced his name right. But he's pretty good, and he goes over a course overview of everything you need to know for the final. So that's great that he did that. I really appreciate him. He also goes over random practice problems, which is also great. So feel free to look at that. So things that I will post is we will cover the remainder of I know it seems like a lot, but we're going to cover the main concepts of the remainder of chapter 11, 12, 13, and 14 all on Wednesday. And then along with the review videos that he gave that are in these 2 videos and all the information you have here in terms of the ACS reviews and the different extra credit basic homework reviews, you should be good. And his review supplements. So between all that information, you should be good. If I were you studying for the final, I would maybe go through the ACS reviews first. If there's one chapter, maybe a couple of concepts that you need help on, you can go to the slides and just look it up. And if you need someone to explain it, you go to the video, right? So all the videos are posted. The video lectures are posted on YouTube. You can just go there and listen to me talk about it. And then if that doesn't help, you can go on YouTube. So YouTube's over and just look up other videos. Just look up the concept. And also if you need more study help, I'm always available. Feel free to email me and we can either talk on the phone or we can schedule a Zoom thing and do some problems together. So I'm always available for that. Okay, so that's it for now. Good luck. Have a good weekend. Happy 4th of July. And let me know if you have any questions going forward. I mean, before exam 3, but really including anything. Unfortunately, there's no taking the final early. So I know that's always a question that my class has raised, but because we all have to do it on Moodle with the lockdown browser, it has to be very structured. So there's no taking it early. So let me know if you have any questions or problems taking the final, and maybe we can work out something different, but it'll be very difficult. But okay, good luck, and I will see you or hear from you on Monday.